Welcome to the DIY Honda Garage channel. The DTC P16E2 stands for Powertrain Control Module, PGM-FI, Alternator Communication LIN, Local Interconnect Network error. This error indicates an issue with the communication between the battery sensor and the engine control module, ECM, through the LIN circuit. The LIN circuit is primarily used for communication between different modules in the vehicle to facilitate data sharing. The components involved include the battery sensor, which monitors battery voltage and conditions, and the ECM, which controls various aspects of the engine performance. These components can be found in the engine bay. The battery sensor is typically near the battery, while the ECM is usually located under the dashboard or in the engine compartment depending on the specific model. Proper communication per the LIN circuit is essential for efficient power management and to avoid potential engine performance issues. The DTC P16E2 indicates a communication error within the vehicle's LIN circuit. This circuit is crucial for transmitting information like battery status between the battery sensor and the ECM. The battery sensor, located close to the vehicle's battery, is vital for monitoring battery voltage and overall health. The ECM, situated either under the dashboard or in the engine bay, serves as the brain of the vehicle, managing various engine functions and optimizing performance. If the LIN communication is disrupted, it can lead to inefficient power management, which might affect engine performance and overall vehicle stability. Detecting this error requires the use of the Honda Diagnostic System, HDS, for accurate diagnosis and troubleshooting. Several potential causes can lead to the DTC P16E2. Firstly, wiring issues, particularly in the LIN circuit, might create communication failures. These can include frayed or damaged wiring that disrupts signal transmission. Secondly, loose connections at various terminals can prevent proper communication between the battery sensor and the ECM. This highlights the importance of checking all related connections before looking into more complex issues. Additionally, a faulty battery sensor that is not functioning correctly can also send incorrect data to the ECM. Lastly, a malfunction within the ECM itself can lead to this error code, making it critical to assess its operational integrity during diagnostics. The presence of DTC P16E2 can manifest various symptoms that can affect the vehicle's performance. One of the primary indicators is the illumination of the check engine light on the dashboard. Additionally, drivers may experience battery performance issues where the battery may not charge effectively or may drain quickly. This can be coupled with inconsistent engine performance, where the engine runs rough or has difficulty starting due to miscommunication of vital data. Moreover, drivers might observe dimming lights or power fluctuations as the vehicle's power management system struggles to obtain accurate information. Recognizing these symptoms early is vital to prevent more significant electrical issues down the line. For the first troubleshooting step related to the DTC P16E2, start by turning the ignition switch to the on position, also referred to as on 2. This will wake up the vehicle's systems and allow for diagnostic checks. Next, use the Honda Diagnostic System, HDS, to clear any existing diagnostic trouble codes, DTCs. After clearing, ensure to wait approximately 10 seconds, allowing the systems to reset properly. Once this period is over, check to see if the DTC P16E2 is still indicated within the HDS. If it appears again, progress to the next step in the troubleshooting guide. Conversely, if the error does not reappear, there may be an intermittent issue, and further investigation into poor connections or loose terminals can be warranted. In the second troubleshooting step, continue using the HDS to check for any pending or confirmed DTCs. Specifically, you are looking to see if DTC P16E2 is indicated. If this DTC is present, it suggests that there may be additional issues related to the LIN circuit that need to be addressed. In this case, proceed to the next step, Step 3, to explore the issue further. If DTC P16E2 is not indicated, then you should consider there may be an open circuit or other problems. This requires going directly to Step 5, focusing on further diagnostics of the wiring and connectors involved in the LIN circuit. To determine the possible failure area associated with DTC P16E2, begin by turning the ignition switch to the lock position, also known as lock 0. Next, carefully disconnect the battery sensor 2P connector, which connects the battery sensor to the vehicle's electrical system. With the connector disconnected, check the continuity between test points 1 and 2. In this case, test point 1 is the battery sensor's number 2 terminal, green wire, and test point 2 is a known body ground. The test should be conducted under the condition that the ignition switch remains off, lock position. If continuity is found here, it indicates no issues with the connection to the body ground, and further diagnostics may be necessary. If continuity is not present, it leads to the next troubleshooting stage. In this step, checking for a shorted wire along the LIN line is essential for resolving DTC P16E2. Use the HDS to jump the Short Circuit Reset (SCS) line, which allows the system to continue with diagnostics. While you perform this, check for continuity from the battery sensor 2P connector terminal number 2 to the body ground, disconnecting 2 connectors one at a time, the alternator 1P connector and ECM connector B, 49P. This step is crucial in identifying whether there is any interruption in continuity caused by short-circuiting or grounding within the LIN wire. If continuity fails to exist when a specific connector is disconnected, it indicates that the wire is operational and the other component needs replacement. If continuity remains, it suggests a wiring issue that must be repaired. Proceeding to Step 5, the process focuses on checking the integrity of the LIN circuit, where DTC P16E2 is concerned. For this diagnostic, disconnect both the alternator 1P connector and the ECM connector B, 49P, ensuring that the ignition switch is still in the lock/0 position. Then, check for continuity between the designated test points, ECM connector B, 49P, terminal number 16, tan wire, and alternator 1P connector, terminal number 1, also tan wire. If continuity can be established, this indicates the LIN wire is functioning correctly, which would necessitate replacing the alternator to resolve DC output issues. Conversely, if there is no continuity, it directs the technician to assess and repair any open circuits in the LIN wire between the alternator and the ECM. As a follow-up to the previous diagnostic steps, this 6th step reiterates the importance of assessing open circuits along the LIN line relating to DTC P16E2. Start by, once again, ensuring the ignition is in the lock 0 position, while both the alternator 1P connector and ECM connector B are disconnected. Then, check for continuity between the same points, ECM connector B, number 16, tan, to alternator 1P, number 1, also tan. If continuity is present, then there is likely no issue with the LIN wire itself. In this scenario, updating the ECM to the latest software version is necessary to check for resolved issues. Alternatively, substituting the current ECM with one known to be functional will help verify if the original unit is problematic. Conversely, should there be no continuity, it reiterates that an open circuit in the LIN wire persists and necessitates repairs. In the final repair verification step for addressing DTC P16E2, you begin by turning the ignition switch back to the lock 0 position and reconnecting all the previously unplugged connectors securely. This includes the connections for the alternator, battery sensor, and ECM. Once everything is reconnected, switch the ignition to the on 2 position to power the vehicle's systems. You will then need to reset the ECM using the HDS to clear out any residual codes from the memory after the repairs have been made. After resetting, conduct another DTC check using the HDS to verify if DTC P16E2 is still indicated. If the code reappears, this suggests further attention is needed, potentially due to loose connections or if the ECM requires replacement. If there are no indications of this DTC, the troubleshooting process is completed with the vehicle fully operational. Preventive maintenance is crucial to minimizing the recurrence of DTC P16E2 and ensuring optimal vehicle performance. Establish a routine where the wiring associated with the LIN circuit is regularly inspected for any signs of wear, corrosion, or damage that could lead to communication failures. Furthermore, ensure that all connections are secure and free of dirt or debris, as loose connections can trigger erroneous error codes. Regular updates to the ECM software should be scheduled, as manufacturers often release updates to improve performance and reliability. Additionally, monitoring the performance of the battery sensor will help in early detection of possible issues, allowing for proactive measures. Lastly, carrying out routine diagnostics using the HDS can assist in the early identification of any potential new or recurring DTCs before they become more significant problems. In summary, the DTC P16E2 pertains to a critical communication error within the LIN circuit, specifically affecting data exchange between the battery sensor and the ECM. It is essential to carefully check wiring, connectors, and the operation of these components during the troubleshooting process. Following a systematic approach through the outlined steps allows for accurate diagnostics and effective rectification of the issues present. Once repairs are made, a thorough verification is necessary to confirm that the DTC has been resolved and that no additional error codes are present. To prevent future incidents, adopting regular maintenance practices is recommended. This includes continual monitoring of both hardware and software aspects of the vehicle's technology, ensuring that it operates reliably and efficiently. Please like and subscribe to the channel. See you next time.